Okay, perfect. So good evening, everyone. We hope you all are having a wonderful day. And on behalf of the TAMS Research Organization, we're so excited to welcome you to Research Symposium today. And we're looking forward to an exciting afternoon today, exploring the possibilities of research and discovery in the fields of both computer science and engineering. And as you can see, we have a panel of esteemed researchers and professors who are excited to share with you their research experience and what it's like to be a faculty member. And after we complete the panel discussion, we will host networking sessions via some breakout rooms. And this will just allow the students to, get to know the professors better on an individual basis. And if they have any specific questions about their research, they can ask them there.
Yep, and in addition, for the students here today, if you have any questions at any time for any of the panelists, feel free to ask them in the Q&A tab, and we'll answer them at the end of the prepared questions. So with that being said, without further ado, why don't we go ahead and introduce to you our panel today. First, we have Dr. Lingzi Hong from the Department of Information Science. We have Dr. Krishna Kavi from the Department of Computer Science and Engineering, and also Dr. Najendra Gulud from the Department of Computer Science and Engineering. And before we begin the questions, would each of you be able to give us a brief introduction of yourself and what your research looks like? We can go down the same line, Dr. Hong, Dr. Kavi, and Dr.
Gulud. Okay, so first I'll introduce myself. I'm Lingzi Hong from Information Science Department. I joined UNT since 2019, so that's my second year here. I have a PhD in University of Maryland, College Park, in information studies. And so my research area is mostly data-driven for social good. So that's like using large scale of digital traces to model like population behaviors, like social networking behaviors, mobility behaviors. So most of the time we look into this kind of like behavior in the crisis, in the crisis situation, like in the disasters, or like when there's like riot, social movements. And we want to learn this kind of behavior so that we can better serve like the policy decisions, to enhance the policy decisions. So I have worked on several projects. So for example, like some like a research project supported by the work, which is about using large-scale digital, large-scale cell phone records to predict the socioeconomic levels of developing countries. And I've also worked on research projects trying to identify the evacuation behavior patterns for hurricanes, before and during hurricanes. So I think pretty much like things about me, some simple introduction. And if you would like to know more the other like ongoing project details, maybe you can come to me like after 5:30. I believe there will be a breakout session for individual professors. Okay, so thank you.
Thank you, Dr. Hong.
To introduce myself, as you probably can guess, I've been around for a long time. Compared to the other two, colleagues of mine here, I've been a professor for more than 35 years now. So I've done lots of different things. I've been at the UNT for 19 years now. I was a department chair for 8 years, and I ran the NSF Center for the last 10 or 11 years. So, and I've done lots of different things. But primarily my research is in computer architecture, which basically means how do we design better CPUs, better multiprocessors, better memory systems, and all the necessary tools to define compilers and so on. So we've designed a processor for a very high performance computing, like scientific computing, as well as very low end processors that go into cell phones, not as cameras, probably simple cameras and those kinds of things. And we also have done a lot of work on cybersecurity. So both hardware level security as well as cloud level security. Some of the tools we developed about 2-3 years ago are actually used by NIST for some of the cybersecurity analysis and so on. And let's see what else. Yeah, lately we are looking at cybersecurity for advanced manufacturing. You probably know that UNT has this Center for Agile, what we call it, Additive Manufacturing Center. They received about $10 million from the state of Texas. So we are working with a group as to what are the potential security attacks you would have on advanced manufacturing, like 3D printers and so on. So we're trying to help them. How do you prevent them and so on? So that's general scope, but I've done a lot of other things. I've been quoted in the Manchester Times and all of those for some of the work I did on airplane black boxes. How can we do better black boxes and stuff like that? So I was quoted in the New York Times as well as Manchester Guardian and all of those based on that.
Sounds great. Thank you, Dr. Kavi.
Hello, this is Nagendra here. Dr. Kavi and I work very closely in the systems lab at the Computer Science and Engineering department here at UNT. Like the first speaker, I also joined back about a year ago in 2019 fall. So I've just completed a year with the university. And I also come from an industry experience. I used to work for about 20 years or so at Texas Instruments before I made the move to be a part of the academic environment here. So I come from essentially a lot of experience in chip design, chip architecture, and the whole ecosystem of developing and productizing semiconductor chips. So my areas of interest are very similar to what Dr. Kavi mentioned, in terms of architecture, both high performance as well as low power embedded, and all the surrounding aspects. I'm interested in some of the software tools aspects, such as what is called electronic design automation. Electronic design automation is an area where there are tools, mostly software tools, that are aimed at improving productivity and correctness and quality of semiconductor designs. And that's an area that's interesting to me, especially recently with the advent of a few billion transistor integrations, very, very large scale integrations. How do you do it correctly and quickly and achieving high performance and so on? That's an area where tools make a big difference. And also another area that has been that's become very popular is accelerators for newer applications. As you know, Moore's law, which basically kind of predicted that you will have doubling transistor capacity every 18 months or so, is no longer holding true, just because of the laws of physics, and we have shrunk transistors to be so small, you cannot shrink them anymore and continue to gain, technology advantages for free. So now is when architects are really pushed to the edge to actually innovate and do things. And the trend is now towards building specialized architectures so that you can get more compute benefit at lesser overheads and reduced power. And as one of the areas of interest there is accelerators for machine learning. And our group has kind of been working with the industry, actually. We have a project that is funded by the Semiconductor Research Consortium, or SRC, which is interested in looking at techniques for low power machine learning hardware. And we are actually kind of working on developing some prototypes and some experimental evaluations at the moment. So that's just to give you a quick feel for the kind of work that our group does. Thank you.
Yeah, thank you, Dr. Galur. And I mean, with that, I think we can just jump right into the questions. And so starting with, we want to kind of figure out what the role of a undergraduate research looks like in your lab. And so what would you expect from a TAMS researcher in your lab? And you could discuss, lab activities, how much commitment you want from them, like the timings, and what you expect with like communication and general responsibilities in the lab.
Dr. Kavi, maybe you should go first.
Again, I think what I would like to find out is what the student wants to do. For example, what's the student's interest first we bring the student into the lab and say, here are the different projects we are working on. And I'll ask my graduate students to tell what their needs are and where can they use their most help from other researchers. And then we'll sit with the TAMS students and say that based on what area they want to work on, we'll try to carve a problem for them to work on and then try to help them completing the project. So I'm sorry that I was distracted, so I didn't hear the complete questions. My department chair walked in to do something. So, but anyways, I hope I answered, the question, what you're looking for. So.
Yeah, that was perfect. Dr. Hong or Dr. Galur, do you want to answer the question as well?
Okay, maybe Dr. Geller, do you want to start?
No, please go ahead. I can jump in later. Yeah, thanks.
Okay, thank you. So I think like my lab, right now I have several projects ongoing. So one is joint fellowship with UN Women and UN Global Pulse. Is using the social media data to understand like gender equality in different countries. Another is actually about crisis communication. So I think, and there are some like other new projects proposing. So depending on the level of your expertise, I think like depending on your interest, you can work on like different projects and also like different tasks. I think like some of the tasks might require like very little prior knowledge. So for example, but mostly this kind of work is like laboring work, like data labeling, data collection. I think there are also some tasks like if you have some programming skills and you have a relatively solid statistical background, you can help with like data preprocessing, data cleaning steps, and also like exploratory data analysis. I think if you have some like relatively good like reading and writing skills, you can mostly help me like in the writing works like literature review. I think if you are a fast learner and have very solid math background, you may join as like the key part of the project. Like for example, join like the data like creating of new data or develop a web application like kind of key component. So basically, on every step, in every step of this data science project, you can join in, and I'll try to find out which method you like, or based on your background and prior experience. So I think some general general information about my. Thank you.
Thank you, Dr. Hong.
Mm-hmm.
Yeah, I think it's kind of similar with our group. We try and fit our TAMS students into research projects that we have got running. It could be on cybersecurity, it could be on architecture, it could be on embedded systems, it could be on other kinds of tools. So based on interests and skills, and we try and allocate students to respective projects. And I think that's kind of a win-win because our senior students in the lab, our graduate students, can more closely interact with our TAM students and provide a way to kind of start them up or get them oriented. And that way the younger students who are interested in getting exposed to research get a kind of a softer entry to working on research projects. And at the same time, as they become more expert and familiar with some of the research project work, they can start contributing over the period of the year or so that they are a part of. And I've kind of personally been exposed to, back when I started last fall, and we had a few STEM students writing to our group and joining us. From that time to now, which has been about a year or so, there's been a huge amount of progress in learning curve I've seen the TAMS students go through, and they're starting to contribute a lot more. And the fact that they can stay engaged with us for over a year leads to a lot of valuable work that they can get to do. And hopefully there's a lot of good takeaway from them as well at the end of their work with us. So, yeah.
One thing I just want to comment, the way we normally do is we have, even though we have different projects, we require everybody working on all the different projects to meet once a week as a collective group, and everybody reports what they're doing and so on. The main purpose of that is, even if you're not working on a particular project, listening to ideas in other projects, sometimes you might say, hey, I can use that idea here. So you would have some cross-pollination, and things like that. And also somebody may say, hey, I already solved that problem. This is how you rewrite your code so that you will solve the problem. So that kind of interactions, at least in my experience, I felt were very valuable. And so at least I require all students, whether they're working in cybersecurity or something else, but meet with us once a week. So.
Thank you all for those wonderful tidbits of it. So now we want to focus on a little bit about COVID. So how has the virus impacted the lab experience, and how has your lab specifically transitioned to do remote research?
I'll go ahead and say it hasn't really impacted as much, because most of the stuff we do is on computers, simulations, and those kinds of things. So we make all our systems available to students for remote access. So even if we have very specialized computers, they get to access them. On occasion, if they have to use really unique equipment, they'll come to lab with the guidance of our graduate students. So there are, I think, a couple of projects where they needed to wire some network, which is only available in the lab. So they scheduled a time when the graduate students were there, so they could come and access and do some experiments. But I really haven't seen any, reduction in the productivity or anything like that. So I think the students, continue to work. So.
So I think for my lab, similarly to Professor Kavi, work is mostly can be done on computers. So I think COVID won't impact the lab experience a lot. So all the work will be done remotely. You can connect with the VPN and then connect to our server. And all the required all the required toolkits will be installed in the server. And I think UNT also provides high performance computing centers and enable you to do to process really large data sets. So for the meetings, we usually meet twice a week to discuss the progress of research projects. And I think as a lab member, if you have any technical difficulties, if you have any questions, you can always ask other or me. So there are master students and PhD students working on these projects as well. So you can help each other. And I think all this can be done online as well, schedule a Zoom meeting, something like that. Okay.
Yeah, I think yeah, most of it was already stated. Just to add to that, we also try and make sure that we keep all of our code on some open source repositories such as GitHub, so that we try and be as specific machine independent or agnostic. We can push and pull code from the GitHub repo and get ourselves up and running, and don't really require specific resources if that's the way we can operate. And most of our projects, we have tried to operate like that recently. So that way we kind of get a little bit decoupled. And yeah, I think the one thing that I miss is not being able to go step into the lab when I have a quick interaction or a quick check to make with one of the students, or have the students come into my office and talk for a quick 5 minutes to exchange some ideas or to sort out some topics. Unfortunately, I miss that because I'm working remotely. But I'm trying to make up for that by keeping, like Dr. Hong said, keeping the Zoom option open all the time. So the students can kind of reach out and drop a quick note to jump on a Zoom meeting, and we can get on with resolving topics instead of trying to set up too many prior kind of appointments kind of routine. So try to keep lightweight and be responsive, even though some of us are remote. So that way we can hopefully reduce any latency for students to get their answers and kind of try to keep the research going. Yeah.
Yeah, thank you, thank you. Our next question, we've kind of already covered this, but what are some prior skills that you think would be very beneficial for TAMS students to already have prior experience with, or start learning now to be able to contribute more effectively to the projects in your lab?
This time maybe we'll change the order. Dr. Guluru will go first.
Okay. Yeah, I think I think it depends. The answer depends on the domain that the lab is basically engaged in terms of research. And in our lab, we obviously like if the students have a little appreciation for some of the topics that we are researching in, and mostly it kind of boils down to some appreciation for security, some appreciation for computer organization, some knowledge of, and definitely a knowledge of programming is almost across the board useful. And languages vary depending on what aspects the research is really looking at. Some of it could be a low-level language like assembly programming. Some of it could be kind of a higher level thing like C or even Python if it's more of a tool development. But yeah, certainly some good programming skills. In general, we find that it is increasingly very, very useful to have, regardless of the projects that the students are working on. Additional things that are kind of softer but would be useful is just when, like Dr. Kavi mentioned, we have a weekly meeting, and when students jump into the meeting, especially given the COVID remote nature of our meetings, it would be nice if the students can kind of come in and articulate what they are working on, and communicate what progress they made, where they are stuck, in a way that kind of helps us help them. I think that's kind of really the expectation in terms of communication. But yeah, I think from what we have seen, what I have seen over the last year or so, I think all the students that we have already been working with have been extremely excited and very actively engaged all the time, students, with our research projects. So yeah, I think it's kind of been really positive so far. Yeah.
So is this my turn now?
Yeah.
Okay. So I think if you don't have any like knowledge, can help with some like laboring work like data labeling, data connection, and the communication work. But I think like probably like most of you still would prefer to learn new things in the research, and not just like contributing some labor work. So I think if you have some basic programming skills to help with data analysis, it will be good. And if you have very solid math or statistical background, but not good at programming language right now, I think you can still be qualified to do some work. But I think still like as a high school student, like to my knowledge, if you need to work on like some key component of the research projects, probably still like take some time for you to learn something. So for reference, like there was a TAMS student working with me right now. So he found me. He said like voluntarily working with me, and he have some basic Java programming skills. I think it took him about like a summer to be adapted, to learn like how to work with Linux system, to learn some basic natural language processing techniques. Then starting from this semester, he can really work on some like feature engineering work, some data cleaning, data pre-processing. So so I think like for me, I didn't expect like very high from TAMS students. I'll give maybe some months to learn, and I'll guide you to learn, so that qualified to really work on something. So yeah, I think that it would like both can benefit from the from this kind of like progress, like from this kind of like projects together. I'll try my best to help you. But like, to be honest, it won't be very quick. Like you cannot get something, like for example, some published very soon, or some projects we done very soon. Like my knowledge, I feel like you still have a lot of things to learn before actually achieve something. Yeah, so that's my
Yeah, thank you, Dr. Han. And I mean, I guess, and before we move on to like the next question, for all our TAM students in the audience, if you have any questions, you know, just feel free to ask them through the Q&A function on Zoom, and we'll make sure to answer those questions when it comes time for the Q&A session.
Okay.
Sorry, I can't remember. Dr. Kavi, did you want to add anything
Oh,
to that question?
really, you know, not really anything. I think the others already mentioned some of the skills. One of the things I always liked about the TAMS students for the last several years is their willingness to learn something new. You know, so they are willing to work hard and learn. I don't remember doing anything like that when I was in high school. So, so I think things have changed quite a bit. I remember 3-4 years ago, one TAMS student, and some of you may know him, David Hash, he came and on his own basically said that he looked at some of the tools we developed and he played with it before even coming and talking. And so he already got everything prepared, you know, to come and work directly. And as a matter of fact, that summer, he was hired by AMD as an intern because he was doing so much work, even though AMD doesn't hire high school students, you know, as interns. But David Hash went and worked for IBM for during AMD for summer, and then he's at Carnegie Mellon. I think he's probably senior by now at Carnegie Mellon. So that's what, you know, to take initiative and willing to work hard and learn. That's what I look for. So.
All right, thank you, Dr. Kavi. But yeah, now we'll move on to our next question. So as you may all know, TAM students are highly motivated and participate in various research competitions throughout the year, such as ISEF, poster presentations, and symposium-like competitions. So with that being said, what parts of lab research are students allowed to present or share at competitions?
Most of our research is funded by federal government, so we don't really have any specific restrictions as to what can be presented or not. And of course, the students should, you know, first thing is it's their work, their contribution. We have, you know, usually allow them to do it, even if it is not theirs directly, but is relied on some other graduate students' work, as long as they get permission and, you know, give acknowledgement saying that where they got to work. I personally don't have any restrictions on what they can present. So, you know, unless there is a company restriction, which is very rare, you know, we allow students to use them. So.
So I think like for my lab, if you independently work on some project and you, of course, like if you write the code, you can publish it, for example, in GitHub or like share with others, or like if you help applications, you can share like share your share your research results to like as a competition. But I think if you just like as a collaborator, some steps in a project probably not claim to be your own. Basically, like for all the things you have done, like you can present it somewhere, like according, like similarly to Professor Kavi said, unless it's like by some policy, it's like open to any competitions, publication, or like sharing with others. Okay.
Sounds good.
Mm-hmm.
Thank you. And I mean, I guess we've kind of talked about what it looks like for the role of a TAMS student researching in each of y'all's labs. And so now let's kind of talk about some more interesting aspects of the lab. And would y'all like to share some, fun or interesting experiences throughout your research career? And, maybe even tell us about, some of the most difficult experiences you've had in the lab and how you kind of overcome that.
Maybe Dr. Hong should go to first this time, just changing, rotation, so.
Yeah, sure. I'm very happy to share maybe like some interesting experience through my research career. I think like I really started to do research from my first year in PhD. And like very new person, like in different in the research I actually like don't know things. So I think my advisor helped me a lot, like help me a lot to grow as a researcher. I think at first, like I had many difficulties, and I on some projects working with the cell phone records, and there are a lot of like difficulties, like to how to identify, for example, different types of users in the data, how to extract different kind of behaviors based on the records. And at that time, I was also very eager to get some like good results to work with some complicated models. It's like the more math in your in your paper, like you are very to do something. But later I find out it's actually like arrogant opinion about like more complete math, like better project. So I think the exciting experience started when I actually can find some very interesting things out of the data, like through a long of like failures and trying. So for example, like working with the cell phone records, actually you can imagine like how many processing steps you need to do to actually identify the individual users, to actually be able to observe like some behavior patterns from it. And so I think through this kind of like very long process of exploration, and from like knowing nothing about research to actually have a little bit have more understanding of how to do a research, this process is like very precious for me. And I remember like the first time I really find something, it's like I think it's like washing a lot of sand to get a little bit gold. And so this time, like even you have very long process of uncertainty, like you don't know whether you can actually get to some results, like a lot of uncertainties, a lot of failures, and finally you can get a small finding that is valuable, that is like the most fun part. And I actually realized that in all the other kind of research projects, and this similarly long time of tedious work, then get a little bit valuable things. So, but I think I really enjoy this kind of like process.
Dr. Galuri, you want to go next?
Sure, Dr. Kavi. Yeah, I think speaking of challenges, I think I can kind of relate to maybe two things that I would like to emphasize. Number one is the field, almost all research fields these days, are tend to be competitive and fast-paced. Whether it is AI and machine learning that you hear almost in every area of research endeavor, or things like cybersecurity or even others, there is the whole thing kind of moves quickly depending on the topic. There is almost 100% likelihood that somebody else out there in some other group in some other university is kind of most likely looking at very similar problems, because the research envelope is it's kind of what it is, and everybody is kind of on that envelope trying to push the bar. So one challenge and advice I would have for our TAMS students is, when you get on board, kind of expect that level of competition, and to get ahead requires a lot of hard work in terms of doing the groundwork, doing all the required prior studies, to catch up to what the current state of the art is, and then to start thinking as to what is new, what new things we can bring given the challenges that are still present in the current state of the art research contributions, right? So that's the first thing. The pace at which things move can be daunting when you get on board, but that's what it is, and we kind of have to run with it. The second one is something again that I learned personally when I went through my own PhD. Back when I finished my PhD, was a comment that I heard from my advisor, that no matter what, you kind of have to keep the bar very high. And this comment that my advisor made was when I was kind of struggling to get some of my papers accepted in the top tier conferences, right? I mean, in our field of architecture, most of our publications appear in conferences and not so much in journals. So the conference is where you really have to get your best work accepted. And I had some trouble in the initial submissions. I was getting feedback and I was basically getting rejected. And that was when I was tempted to think, okay, instead of tier 1 conferences, maybe try the same ideas at a tier 2 conference, and hopefully they might accept, and why not? And that was when my advisor kind of caught me and said, no, we should never lower the bar. If we don't make it tier 1, let's incorporate the feedback, understand what was the deficient in the work that we did, and go back and try again. And that's something that I have carried with me ever since. I think keeping the bar high, no matter what it might feel like. It might be like depressing to go bounce from conference to conference 3 times, 4 times, getting rejected, is okay, as long as you're learning from it and improving the quality of the work that you're doing. It's all for the good. I mean, there is no shame in getting rejects and so on, as long as you're able to kind of learn some lessons. At least those are 2 things that I wanted to kind of mention. Thank you.
Yeah, I don't really have a lot of new things, but since I've been, as I said, professor for more than 35 years, I have a lot of different experiences. And I claim I'm an engineer. I'm not a theoretician. I'm not somebody who looks for a perfect solution. I want a solution that's feasible, solves the problem, right? So that's all my approach. I used to have a discussion with one faculty member who was more mathematical, and he used to say that, oh, my paper has 13 theorems. And I said, who cares if you have 13 theorems or not? Is it useful or not, right? But anyway, so I'm an engineer. So basically, I look at problems like that. And I always encourage my students to come up with some engineering solutions. I'll give you 2 examples. The reason why I even got involved in the black box research in the airplanes was back in 1998, when Egypt Air crashed. I had a PhD student, an Egyptian, and one of his friends died in that plane crash. So when our transportation NTSB wrote a report saying that the pilot crashed the plane, he didn't believe it. He kept, of course, even now, Egyptian government doesn't believe in that. They claim that there's a mechanical problem. So he came and said, why can't we have a solution for this? Why can't we have the black box continuously transmit data to the ground? And so we said, okay, let's go and investigate it. So we went to NTSB, we collected tons of data, we analyzed, and we learned a lot, what happens in the black box and so on. So we proposed a solution. This was in 2001 or 2002. In those days, because everything is regulated by federal government, most of the airline companies said, unless federal government is going to require, we're not going to change what we're doing. We're going to continue to do this, and so on. And finally, I think when Air France crashed in, 2007 or 2008, and they, talked to me several times and so on, a company in Canada started building these new black box type recorders, which continuously transmit the data. So now they have the capability to transmit the data. Again, they're not still using it because federal government doesn't mandate it. So during that, we did a lot of analysis of what kind of communication systems you need, because planes, when they fly, they have to change the communication medium. If it is on the ground, you can use microwave, you can use cell towers. But if you're flying an ocean, the only communication you have is through satellites. And satellite is slower and expensive. So we had to do all this analysis and present that. Second example, a very interesting solution we explored was, one of my students was driving on a highway and just got off of the highway. It seems he didn't notice the speed limit dropped from 60 miles to 30 miles as he exited. So he got a ticket. And he got so upset about it, saying, why can't we find a solution where I should have been warned in my car directly, saying that this is the new speed limit and so on. So we prototyped a device, and at the university where I used to work before here, they allowed us to set up a environment test bed. So we put these small transmitters at every stop sign and on poles. All they did was to continuously transmit the speed limits. And you have a receiver in your car, so it displays the current speed limit is this. And we proposed so many alternatives, saying that if there is rain, you can automatically change speed limit. You don't have to go and change, speed signs at all, because it's all electronic, right? So, we presented that. Again, we were ahead of time because the transportation department said, oh, we don't care for gadgets. What we want is safety. As if this didn't solve the safety problem. But anyway, so now with all these autonomous vehicles, our solution is almost mandated. Now it's needed, because otherwise how do the cars know what the speed limits and so on? So they continuously transmit. Actually, I have a lot of contacts with Taiwan, my former students, they're there. Taiwan actually installed those things already when we're doing this. So, but we are sometimes behind. So what I say is, you need to be passionate about something. You need to say that, hey, there is a problem I want to solve, right? And then go and try to do it. So that's my 2 cents.
Yeah. That's very interesting. Thank you, Dr. Kavi. So for our next question, I think Dr. Gulud kind of briefly touched on this, but in your research careers, what was your most difficult experience? and what insights that help you gain?
I think I agree with Dr. Guluru in saying that not getting recognition for your work is always sort of makes you feel bad, right? So you feel that you have very good solid results and so on, and somebody tells you, oh, this is not worth it, you know, and reject the paper, particularly in good conferences and so on. But, you know, we need to keep trying. But when you get the recognition, you maybe, you know, after many years, but you feel really good about it. So that's what, you know, my advice would be. Even if you feel that people didn't recognize, if you think your work is good, keep doing it, and one day you will get the recognition.
Right, so I think I agree with both professors here. It's important to keep yourself motivated or, in the research. So for example, maybe read a book or like watch movies, you actually get some like enjoyment, right? Very quick to keep. But for research, most of the time you get something in delay. So for example, like get recognition in delay, like sometimes it's actually like maybe difficult for you to actually get some recognition for your work. So it's not a easy road, but it will be very valuable because you know that your work may be valuable, your work like some impact for someone, your work may help like a lot of people. So this kind of like, I think this is like some I go to achieve like very instant enjoyment, instant stimulus. In the long run, you will feel like you learned in this process, and you also some impact with this kind of like research work you have done. So I think the difficult thing, as I said, is like to try to motivate yourself all the time. So I think that's also very important that you have some passion, you really have some interest in some research questions that drive you to do these kind of things. So I think I really agree with Professor and Guler here. Like you need to find something you are interested to work into. It's not like just to publish some paper or not. It's like you are really interested in the question. It's about getting something out of it. It's about like trying to make yourself better and also trying to make your work impact, have impact. So this is I see research like part about research work, different from some other things. Yeah.
Thank you, Dr. Han.
Yeah, I think the other aspect, maybe it's a little bit specific to systems work that we do, is systems works are not like are unlike maybe things that you might study in terms of a math proof or kind of an algorithmic description you might study in a CS fundamentals course, right? Where there's a small algorithm and a nice proof showing that the algorithm is correct and things like that. Systems work is kind of not like that, right? I mean, oftentimes you kind of work with empirical things. You have some heuristics or intuition, what might work, what might not. And to demonstrate that you have a good idea that is practical, feasible, takes a lot of work. I mean, you may not be expect to go build a real system because it's just too time consuming, too expensive. But even to demonstrate that the idea is sound in terms of that it takes care of all the corner cases, it can be put to use effectively in the field, and so on. It takes a lot of work in terms of understanding real systems and simulating various kinds of experiments. Sometimes you might see that it is very cross-functional in nature, right? I mean, you have to understand applications, you have to understand operating systems, you have to understand programming and compilers, and you probably have to understand the underlying architecture. And it's kind of, each of those things is a giant body of work and a specialization in itself. And oftentimes when you're in a systems research area, you kind of have to bring an understanding of all of these things to really kind of make your work add up to some good thing, right? And that's also a challenge, because you need to have that kind of a more cross-cutting competency, or at least an appreciation for what else is going on, so that when you work on your piece, you kind of need to know how it affects and adds to the whole bigger solution that you're looking at. So that picture is hard to develop. It takes a lot of understanding. It takes maybe a lot of reading of the bigger system that we are a part of, and then kind of trying to see how the jigsaw puzzle gets solved, so to speak, right? So I think there is a lot of that kind of understanding that one has to bring, and that can also be challenging initially. If you're completely new, it might feel like, where do I start getting a hold of this picture? But once you get started with in the area that you want to get into, over time, I think you kind of need to develop that big picture. That kind of makes you more successful in terms of the ideas and how to critique ideas, how to pursue the ones that are more likely successful, how to drop things that look very fancy, theoretical, may not really, be meaningful to try out, and things like that, right? You kind of have to develop their intuition.
Yeah, thank you, Dr. Guler. And I mean, it seems like that the one point that our panelists are trying to drive home, that like when you're starting research, try to choose something that you're passionate about, something that you love. And when you start with that passion, who knows, it could become a career from there. And I know we've talked a lot about, or our panelists have shared a lot of advice, for being in like a research position. But I just want to like ask, like, do you guys have, any other pieces of advice that you'd give to a student planning to go into research as a profession?
I think, I assume that the other two will support me, saying that you need to want to do the research, right? So it's not, so for example, as you probably know, professors don't make as much money. Several of my students try to hire me at Intel and other places, basically saying, hey, Dr. Kavi, I'm making 4 times as much as you're making. Why don't you come and work for me? The thing is, you have to have the passion to say that I'm interested. I'm training a new set of new researchers. For example, I graduated at 25 PhDs and probably about 50 masters and maybe thousands of undergraduate students. But you have to say that, you're playing that role. So you have to have the passion to do research. You want to, say, train new calibers, new, batch of students, a new generation of, researchers and so on. So, and even if you don't go to academics, even if you go to industry and national labs and stuff like that, again, you have a different passion. It's not like, I'm going to build a new company and make a lot of money, but you say that I'm trying to solve some problems, whether those are problems, solving some societal problems, or some fundamental problems, whatever it is. So.
Thank you. So I think I'll just add some few things. So I think to develop your career as a researcher, it's very important to have critical thinking. Although it's also very important for other professions. Especially, I feel like people in research area that the most critical people. So that when you ever see some conclusion, you can practice when you see some conclusions, always think about how the conclusions is made. Think about and how they whether there are any questioned in the process of getting to this kind of conclusion. So this is just some of practice in your in your life, whenever you see anything, always think about, for example, when you see the COVID-19 cases, you can think about how they get this kind of data, whether there are certain bias, whether people are over or under-reporting these kind of data? And is it similar for all kinds of across all states, across states with the political bias? Things like that will try to like make your mind like more keen towards all any kinds of questions. So for researcher, like you always need to publish something, right? So when you publish, actually there are like peer reviewed process. A lot of people will come out and judge your process, like saying, okay, you have some questions, you have some questions there. So enable, like make your work to be published top tier venues, top tier conferences or journals. You need to face the criticism from a lot of other like peers, from other people more research experience than you, or more knowledge, who are more knowledgeable. So I think like for yourself to be able to qualify as a researcher, you also need to try to like foster your critical ability, not only in your expertise, but also maybe in whenever you question. Also, I think it's very important, like for researchers to have systematic learning, to build on a very solid base. For example, if we want to have some expertise in a specific area, like in computational linguistics or in computer architecture kind of things, it's very important for you to take systematic courses. You cannot learn things like piece by piece, and like this way you probably learn something, but you won't be able to have a very like big picture of the research. So I think this is also some important thing. So for TAMS students here, I think you are very lucky. You can select courses from like let's say the undergraduate courses. Probably if you are very interested in a specific area, you can like take courses to have to build a very solid like knowledge base, and then develop your interest in an expertise. And I also feel like it's very important to have persistency, to be persistent in doing research. And this is a very good quality. I'm always looking for students to have, because as I said, like usually the not easy way to like it's not an easy work in research. Most of the time you have a lot of like trying and failure. Most of the time you may not get very good results, or you can get some good results in a relatively short time. You will find out that is like the kind of low-hanging fruit, and maybe valuable. So if you can like self-motivated, you can keep trying to learn in this kind of process of a lot of failures, then you will be a very good researcher. So that's my opinions.
Dave, may I suggest it's almost 5 o'clock, and because we've been talking too much here, maybe we should have TAMS students ask us questions if they have any, because it's already 5 o'clock. So
Yeah, I was just about to say.
Yeah, we could open it up to the discussion. And so yeah, for all the TAM students, if you could ask the questions through the Q&A feature, that'd be great. And once we get some questions rolling in, we can just get started.
Yeah, I don't think we have any Q&A questions from students yet. So I guess we can ask one last question and then open it up to the breakout rooms or see if any questions come in. So I think Dr. Kavi, you mentioned that in the years that you've had TAM students working in your lab, you've noticed that they've grown as researchers throughout the course of the year. So with that being said, like in each of your careers as a researcher, what skills do you think that you've gained, and how have they been advantages? How How have they helped you in your career in your field of research?
You know, one thing you have to realize that in your career, you're going to change your research so many times. So you're not going to be working on exactly the same problem for 30, 40, 50 years. It's very rare. There are maybe one or two people who just did the same thing, you know, for the 30 years. So we need to be willing to learn new things throughout, you know. So I keep telling that I had 25 PhDs because I supervised 25 PhDs. So every single one is also involved me working with the students closely and learning so much about it. So, you know, that's something that you never stop learning, you know, so you always try to find new issues and try to learn how to solve the problems and so on. So that's, I think, something that, you know, almost every good researcher will tell you that they keep learning throughout their career. So, you know.
Right, I think I agree with Dr. here. I think the most important ability is the self-ability. And I think like if you are self-motivated to learn anything, then unbeatable. Like you can so this is like the most advantageous, I think. I'll be
Yeah, I think being able to you know, explore new areas is kind of the fun of the research, right? Like Dr. Kavi said, I mean, being able to, if you're in a typical industrial environment, there isn't that much you can do, you know, unless you're kind of spending after hours and weekends to kind of explore other knowledge areas that you want to pursue. Your day job is really kind of driven by what the company's priorities are and the product team that you are a part of, and it pretty much sets your context for what you get to do and so on. So being in a research thing, you know, gives you a tremendous degree of freedom that you don't get in the industry. And yeah, I think students should kind of explore the opportunity that they get, both in the, you know, right at the TAMS level, you know, being high school students, and as they continue to kind of, you know, further their education. I think it's a great opportunity to kind of keep that perspective and explore. I mean, this is the one time, right? I mean, of course, most students probably end up going to some industry and taking up some industrial jobs, which is kind of how things go. But while you are at it as a student, I think it's the best time you have to do research and not be afraid to fail. And in fact, students have absolutely should have no fear of failing. If at all, it's the faculty that needs to make sure, you know, there are some reasonable, good quality publications coming out and so on. There are some expectations, but, you know, students should have no fear of exploring topics and trying to kind of, you know, have some fun and trying to come up with something new, right? Yeah.
I see three questions. How do you want to handle it? Do you want us to take turns and answer directly, or type answers? You know,
yeah, so we'll just read them out loud so that the attendees can hear the questions, and then depending on like the style of the question, just one panelist can answer the question, or each of y'all can answer the question. But the first question we have is, I'm a traditional science student, meaning that they're in the biology track for TAMS, and therefore I'm not in any computer sciences classes currently. What resources do you recommend in order for me to gain more knowledge about computer science?
Because the fundamental for computer science is to be ability to program. So what you need to do is try to learn some programming languages, whether it's C, C++, or Python, whatever you want to learn. And there's so many resources online. For example, if you're interested in machine learning, download some tools and play with it. And so see what, you know, how those machine learning tools analyze things and so on, try to understand them. Because even though it's a computer science, the fundamentals are still math and science, right? So it's not necessarily, you know, related to computer science per se, but we are trying to solve science problems, you know, or mathematical problems. So you can start that way to start with. And in our particular field, as Dr. Guluru said, that our systems is a little bit more complicated because it requires you to understand computer architecture. It requires you to understand something about operating systems and how an operating system manages resources and stuff like that, as well as maybe some compilers too. But that's the next step. So once you understand what are the basics and stuff like that, and there are so many resources available for you. Plus, if you're interested, just talk to some of our students. Come visit our lab someday, and just randomly pick a graduate student and ask what they are doing, and they'll do.
Okay, yeah, so it looks like we've got some questions coming in. So one of the questions is, what is the best way for a student to approach you?
I think it's easiest just to, and I think our emails are there on our websites, and I think there's no real protocol here. I think students who are interested in the area that we work on are just free to drop us a note. And typically what Dr. Kavi and I do is, if a student contacts us, one of us, then we invite them to join one of our weekly laboratory meetings, where all the students come in and talk about what they have been working on. That's the best way for a new student to kind of hear about all the activities going on in the lab. And yeah, that's it. I mean, yeah, I think they can just freely write to one of us, and we'll set them up to come in and get engaged. Yeah, it's pretty lightweight, yeah.
Yeah, I think maybe we three can write our emails in the chat box, and then
I think UNT has standard email. So your first name dot last name at UNT.
Yeah,
so,
right.
Yeah.
Yeah.
Yeah, and students, you can always go to each department page. So whether it be the computer science or information sciences department, and you can look up any faculty member, and you can figure out there should be a little paragraph about their research interests, and it should also give you their email address there.
And probably even link to our web pages with all our papers, our research, and so on. So.
We have a question from someone asking, what did your first research experience look like?
My first research experience was when I was 14 years old. My uncle was doing a PhD in physics, and he was doing some modeling of some molecular dynamics. And he asked me to run some programs. This was a long time back. So they used to have punch cards. I don't know how many of you even heard of computers using something called punch card to get the programs running. So you have to actually sit and punch holes in cards and take it to the computer and read it. So that's my first research experience. Run the programs, collect the data, show it to my uncle, and he validates them and say, no, you made a mistake, go back and run it. So that's my first research experience.
Dr. Hong or Dr. Lulu?
Go ahead, Dr. Han.
Okay. I think I just mentioned a little bit my first very formal research experience is actually starting when I was in my PhD study, and so I remember at first I'm a baby, I don't know anything, and my advisor gave me a lot of detailed instructions, what kind of prior knowledge I need to learn, and what kind of kind of resources I can learn by myself, and what kind of papers to read. And then after the first year, she started to let me to explore by myself. So I think it's at first she my advisor gave me very, very good guidance, so that from the second year I started to apply the kind of skills I learned from the first year, and then started to work on my own. I think like from my advisor, I also like now I also become advisor for many students. So I think I learned a lot. My PhD advisor, maybe from the first step for students who haven't done any before, gave them as much guidance as I can, and then try to foster their ability in reading papers, in doing experiments, in the exploration of data, and a lot of things. And so later, I'll try to like leave them to independently do something and as some supervisor. But maybe for the first step, the advisor's work will be a lot, but it will be very valuable. Like you can see how the students grow. So I think that's my answer.
Yeah, I think trying to recall, I think my first kind of exposure to understanding research was when we were undergraduate school, and the school required us to do some kind of a research project, but it kind of left it very vague as to what the expectation was. And so me and a friend of mine, we wrote to faculty at the Indian Institute of Science, asking if we might tag along and join one of the research projects there. And one of the professors was kind enough to even respond to our email, our question, back then. And first thing that he did, and knowing that we were kind of undergrad students, not really having any kind of research experience, the first thing he suggested was, he kind of asked us a very interesting question. I remember he said, do you like to work on graphics or networking or parallel processing, or maybe some fourth thing? It was kind of a very open question, right? And we hadn't obviously thought about out of the box. We couldn't really come up with an answer. We kind of stumbled for a proper response. He knew where we were coming from. And then he took out a piece of paper and wrote down the names of 4 textbooks, one for each area, one for graphics, one for networking, and one for parallel processing, and I forget the fourth. And he said, read these 4 books, all of them, and come back after a couple of months having read those books. And then I'll ask you questions, and based on how you respond and what I think, I'll see if I can give you something. That was kind of how it started. Right. So the point is, I think a lot of research is, at least initially, a lot of it is reading. Really, it's kind of hard. I mean, I know there is excitement to kind of jump in and try and do new stuff, but a lot of the time it is actually diligence to getting the fundamentals right and building your foundations, reading a lot of literature. Could be just textbooks, could be more papers, but that's kind of how you get how my first thing went. Just to kind of relate to my own personal experience. Yeah. Thanks.
I just want to correct a little bit what Dr. Galuri said. He said he got 2 months. For TAMS students, we only give a weekend to read those 4 books. So I just want to make sure.
Yeah, that's right.
Yeah, sounds good. So it looks like another question we got is there a standard or a common language that you use for the majority of your research projects?
I guess either Dr. Galuri or we both, I think nowadays Python is becoming popular, so it's easier to learn, easier to do initial programming. So we can start with Python, but most of the work we do is like C, C++, so.
Yeah, I agree with that. I think for most of like the data processing, probably Python is very popular and a very good to use tool, very easy to learn tool. For our projects, we also use some other like data visualization tools in the statistical learning programming language like R. But I think these are like relatively easy to learn. Like if you have the willingness to learn, like motivated to learn, that won't be difficult for TAMS students here.
Perfect. And then another question the student asked is, what is one specific project that you are currently working on?
I think Dr. Kavi and I think we kind of covered some of this, but yeah, one specific project that we are working on is how to do efficient low power inference in embedded devices. Embedded systems are kind of these low power devices. Even cell phones really don't count as embedded devices. Cell phones tend to have high performance, but we are looking at devices that are even lower in performance and absolutely must consume very little power. And in those systems, there is a growing expectation that they can actually kind of become more intelligent rather than just to be able to send some data and transmit to the cloud, but can they do some embedded inference? And that means, you got to do a lot of number crunching. As you probably know, machine learning, things like convolutional networks have a lot of number crunching requirement or demand on the underlying hardware. And the challenge is how can you do all of that relatively at low cost in terms of both power and storage. So there are techniques like, can you avoid, if you know that one of the operands is a 0, for example, why would you multiply 0 with the other argument anyway? Because the output is going to be a 0, and adding a 0 to something is not going to change the sum. So why bother? So simple techniques like those have become popular, and exploiting them at hardware level, can be challenging. And this is one of the projects that we're currently working on. Thanks.
For me, like currently I have several projects working on, as I just introduced. Like one is a joint fellowship with UN Women and UN Global Pulse, which is using large scale social media data to understand gender equality in different countries. Another project I'm working on is trying to use the open crowdsourced data to trying to predict the evacuation flow during Hurricane Irma. So this is like ongoing project which is going to end right now because we've already like have some results about this. There is another project I'm working on right now is about like automatic extraction of the valuable crisis information, and valuable information in crisis communication for decision making. So it's like have different kind of categories, like the content categories, whether it's first-hand or second-hand information source, and whether the information is facing personal, is like personalized information or localized information or like general knowledge. Like we try to use machine learning model, deep learning models to automatically do this kind of information extraction and categorization. And so this kind of data can be, like after this kind of categorization, they can be summarized into some knowledge for decision making. So that's like 3 projects I'm currently working on. I'm also proposing a new project, but I think maybe I'll just stop it here and then leave Professor Kavi to talk about his.
As Dr. Guluri said, we have several different projects. So since we talked about the architecture side, I'll talk about some of the security work we're looking at. One of the projects that a couple of graduate students working on is security at the home automation level. So if you have everything in your home on internet and basically can control things from any place you want, we feel that you need to enforce different levels of security depending on which device you're controlling. So you can't simply say that you have just one level of security. For example, if you're controlling an oven, you want higher level security for that, higher level authentication and stuff like that, because if somebody turns your oven on, they can burn your house, right? Compared to somebody turning on your TV, somebody turning on something, which may not be as critical. So what we feel that is we have to design different levels of policies for depending on devices and then enforce them. So how do you make sure that when somebody tries to say, I want to turn this thing on, there should be a mechanism to validate whether that person is authorized. Do we need multiple levels of security, and those multi-level in authentication, those kinds of things. So we actually built a prototype on that. So we are extending that and also introduce some machine learning in it, saying that what's the typical habits of the homeowner? So can we learn from that and say that this doesn't look like something that Dr. Kavi does at home normally. So this might be an attack, those kinds of things. So we're building an environment for that.
Thank you, thank you. Our next question is, let me see. Oh, someone was asking, typically what is like the time commitment you expect for, a TAMS student conducting research in your lab?
I guess it depends on what this student wants. I think we want the student to be passionate about it, not necessarily count how much time they're spending on it. So if you're really passionate about it, you don't really necessarily look at the time or commitment. So we want to make sure that you are willing to say that, I'm really interested in learning on this. So I'm going to spend whatever time it takes.
I think for like in our lab, usually we meet like twice a week, and so enable you to have like enough work to report. Probably you need to work like at least 10 hours, like to at least have something to report in our meeting.
Yeah, I think so. I think one of the things we were talking about earlier is, the pace at which the research tends to move. It's kind of funny. If you're in a relevant field of research, there is obviously a lot of competition. There are a lot of smart people and projects out there in the US and across the world. And so I think to become the best and to kind of succeed, it takes effort. And I think students who are working with us should definitely be able to kind of run with the projects as the projects kind of require. We try and often try and drive ourselves by identifying suitable, maybe upcoming milestones that maybe, for example, maybe a call for funding proposals where, by which time we should have some critical motivational data that we want to include in a project proposal that we want to write. Or there could be kind of like maybe a conference publication deadline coming up, and we want to make sure we wrap up our experiments and get our paper ready for publication, right? These are kind of natural deadlines. They provide they act like a catalyst for our work to keep making progress, right? Otherwise, things tend to get slowed down and they run at their own pace, which we don't like. So yeah, I think we absolutely, like Dr. Kavi said, we absolutely love students who come in with all the passion to get on board. And especially with the COVID thing, many a time, it doesn't mean Monday to Friday or anything like that. I mean, a lot of the time I'm talking to some of our TAMS students on a Saturday or even a Sunday evening, right? It doesn't matter because I think they are interested in getting things done. And some of these paper and proposal deadlines tend to help create that momentum for us. And we kind of want to leverage these things. So I think if students come with that sense of trying to get things out the door and see things convert to results, I think that would be excellent. And also, I think, speaking of which, I think even since I got on board, we actually published a paper that's going to appear end of September at a conference. And two of our TAMS students are co-authors on that paper. and they have kind of been working with us for maybe 7 to 8 months now, right? Since the end of last year. Yeah, that goes to show, right? I mean, I think if students are kind of actively engaged, it converts into good results. I think it's no surprise that, you know, good results can come out. Yeah.
Likewise, in a different project, we had 2 other TAMS students that also co-authors in another conference paper. So Daniel and Nathaniel, so you know both. Yeah, but yeah, one thing I think, at least in my personal opinion, and what I've seen Dr. Guluru do, we are here to help students too. So we work on weekends, we work, you know, anytime, you know, we need help. So you should not look at that, how much commitment you need. Are you committed to the project or not, and willing to spend whatever time it takes?
Sounds great.
Yeah. I think on the, to be honest, you know, just to add, you know, there could be instances where students are kind of hanging around, so to speak, in the kind of the activities associated with their projects, but not really driving them, right? And those things kind of become harder, right? We obviously like to support every student, but to a large extent, it depends on, you know, how the student is pulling and driving things also. And therefore, I think the level of progress and success different students make it varies tremendously with the level of pull that the students themselves bring with them. And oftentimes I've seen students who are kind of hanging around in our projects, not really having a lot to report, you know, and kind of weeks go by, and there's not a whole lot of credible thing that has happened. And I think it's kind of how it is, but I think students ought to realize that, you know, I think this is a golden opportunity for them to, you know, being in high school, to be a part of interesting research projects. And I think no better opportunity than this to actually kind of go off and learn something new. Again, like I said, there should be obviously no fear of failure, because there are graduate students and there is faculty to support them and guide them. They're not left on their own. You know, all that we expect is, you know, once the problems are kind of defined, they should obviously kind of go off and experiment and explore and do things a little bit on their own. If they run into trouble, of course, we'll be able to kind of sort them out. But yeah, the initial, the drive has to kind of be there. That would make a lot of things easier to work through.
Yeah, for sure. I think we have time for one last question before we move to the networking sessions. This is more a technical question. So the student asked, what is GitHub and how does it play a role in your research?
Dr. Guluru, you want to take
Sure.
yeah, what GitHub is?
Yeah, GitHub. No, GitHub is basically an open source code repository, right? I mean, I think a lot of open source projects, including maybe if you're a computer science student and you have used something like GCC or LLVM, one of these compilers for compiling your C code, those are all projects that are there on GitHub. So it's, I think the last I heard, GitHub crossed maybe 1 billion lines of open source code that they host. And it's kind of the place for collaborative, coding, where students and faculty, whosoever can basically share code and, develop code and share for others to view and pick up from, etc. So it's kind of become a de facto model across almost all the open source projects these days, software projects. Yeah, so, but that's, it doesn't got a direct implication for what the research is, of course. It's just a tool, basically, at the end of the day, where we kind of try and push our code. So if you and I are developing different modules that have to be compiled together, and, obviously we're not in the same place, we're not sitting next to each other, so we both have to have some kind of a remote code sharing mechanism, and GitHub provides lots of tools to make it easy. But besides that, it is just what it is, right? It's kind of a repo to, develop code, upload code, download code kind of a thing. Yeah.
Just to give an example, GitHub is not just used by us to share code in computer science research, most of you probably know Nate Silver. He's the one in 538, I think blog, he predicts elections based on polling results and stuff like that. Is a very complicated mathematical model, statistical model to take all these results and predict elections. He made his code available on GitHub, by the way. So, so you can go and pull down the prediction, code from GitHub.
All right. But yeah, that brings a close to the Q&A session. So now, all students, we should have sent out 2 links in the Zoom chat. And Dr. Kavi and Dr. Galul, we put you guys in one Zoom room because you mentioned that you guys work together. Does that sound good?
Yeah, that's fine.
Okay. But yeah, Dave and I will be starting each of those rooms in just a minute. So